In the last video, we went through some regression of real estate data, and I still have the plot of that from the previous video. In this video, what we want to do is discuss the other type of machine learning, the other set of algorithms that we've discussed in the course so far, and that's classification. So if I'm a realtor, let's take the point of view of making sure that this is actually useful stuff. This isn't just theoretical. We as professionals in our professional life, and many of you as IT workers and data scientists will be given data and go through all this and do some transformations and pre-processing and all these sorts of things, and we get eventually our regression that we did. And if I'm a realtor, I have two tasks. I buy houses and I sell houses, or assist in the process at least. And if I have a new client that's attempting to sell a house, what I would do is get this best fit regression and go along the line here, and then say, okay, this is approximately on average what these are selling for, and from there use that information. But say I have somebody that comes up to me and wants to buy a house. Well, I would want to classify the data and say they are looking for a bargain. Say they're an investor and they want to find a bargain home. So what we might want to do is classify all the home sales into a bargain or a not bargain. And so what I did is I took our previous numeric data and I turned it into classification data. And so what I did is basically, so we have our price and our square footage, and that's our features. And I made a new feature based off of these two, and that is the price per square foot. And so what's nice about the price per square foot, it doesn't matter. Let me think how to say this. Price right now is a function of square footage, but no, price per square footage is regardless of the square footage of the home. So if it's a rate. So I hope that makes sense. It's no longer dependent on the square footage of the home. It's a new feature based on this, on the price and square footage. And that way, no matter the size of the home, we can decide if it's a bargain or not. And so what I did is I made a new data set, and everything basically below this line here would be a bargain. And so I will open up Weka, and I'll show you exactly how that works. So we have our Explorer, so I click that, and then open up our file that we're working with in data, and I made a new one. So there's our old one, realestate.artf, and our new one is real estate class, and this is classification data. Okay, so we have our square footage and our price, and then now we have a new field, bargain. And as you can see, only the best 1/3 approximately are going to be considered a bargain. And so what we can do then is choose a classifier for that. And so the one we've been typically working with is J48. And let's leave it with no options. We'll just run it as is, and then we'll see how well it does. Okay, and well, it did pretty decent actually, 94%. So in 94 of the cases, it attempted to classify the home as a bargain or a not bargain, yes or no, and then it in 94% of the cases it got it correctly. And so we can see our confusion matrix that we spoke of in earlier lectures, and if there's any lack of understanding on that, go ahead and watch those videos. And then these are incorrectly classified. So let's right now our target is 94%. Let's try to do better. Let's set some of these options, and so we click that, and then so one of the options that we can do is pruning. So let's find that here. Unpruned. Okay, let's go ahead and prune that. And what that is it will essentially make a smaller tree. And then we can click OK. And then let's run a second time. So remember, our target is 94%. And actually, there are many different of these, what's known are metrics, and we'll go over these later, but these are, we spoke of true positive rate and false positive rates, and these other things. I'll make a video just dedicated to that, but for now, let's do correctly classified instances. So we run it. Okay, so it didn't do any better. Let's go ahead and try a new classifier. So let's do this one as known as decision stump. And then we click it to see what options are available. And this one's a very basic one, and you can, I'll have to choose it again here. And you'll have to go to the book for more details on it. Same with J48. There's in the algorithm section, it talks about both of those and what exactly they are. Right now we're just kind of getting hands-on practice with this. So let's see how this one did. And well, this one actually didn't do that great. Only 62%. So if I'm working in the IT department of a real estate agency, I'd say, okay, well, the only metric I really care about are correctly classified instances. And so decision stump didn't do that great. So what I'm going to do, I'm just going to use J48. And then you can play with some of the other ones. Let's do random forest is a very popular one. So let's see how well that one does. And as I should mention that by default, Weka in the ARF data file format will use the last field as the one we're classifying, and because the other two are numeric, there's really no confusion. But as you can see, NUM is numeric, and this last one, NOM, is nominal, which basically means classification data. So let's run random forest. Let's see how well random forest did. And actually, that wasn't too bad. There may be reasons why you may want to do random forest or J48. They're actually very similar, and one of the things that once you have a high classification rate like that, you start to look at some of these other things and say, okay, what was our false pos? Well, okay, so I'll get into these later, but basically these are false negative and false positive rates, and the number of instances that it correctly classified based on this confusion matrix. I'll do a whole video on that, but let's look at the true positive rate just to keep it simple. So this is 9.915, and let's see what the random forest did. This one actually did slightly better, so this might be a reason to choose random forest over J48, especially seeing that it classified more instances correctly. And you can go through these, and there's a bunch of them. Some of these I don't even necessarily know what they do. Let's try this one, LMT. I'm not familiar with this one. And this one actually, for whatever reason, takes a very long time to run. It's only on fold 7. And whatever that one is, LMT, actually did extremely well. But as we noticed, it took a very long time to run. For a real estate agent, that might, and we have a very high true positive rate, we might say, okay, that little extra running time, that was only a few seconds. I'm only going to be dealing with data sets in the size of 500, 1,000, 2,000. I don't mind waiting a little bit longer to be able to get 99% accuracy compared with 62% of decision stump, which ran right away. So I might say I'm going to use this one. And one of the things that you may run into is I just did, and the first thing I'll probably do is once I'm done with this video, look up what LMT stands for and how that algorithm works. You may be using algorithms that you don't even know what they do and how they work internally. So I'm pretty familiar with random forests and decision stumps and J48, how they work internally, but this one I'm unfamiliar with. So I might say, this seems good, but I'm not familiar with this algorithm. And so you just, out of practical experience, you'll probably end up using algorithms that you aren't 100% familiar with, but you kind of just trust the data and it gives you good results, and so that's when you use. So I don't want to let the video run too long, but that's basically how classification works in a realistic example, and something you might use as a data scientist or an employee in an IT department actually running some of this data. So one of the next videos I'll do is start to discuss a little bit more of these metrics that I've kind of glossed over so far, but this will be the second part of your assignment, will be classification.